Hello student, in this video lecture we are going to see the step by step procedure for the analysis of indeterminate structures by flexibility matrix method. So, we already know what is meant by indeterminate structure. Indeterminate structure is a kind of structure which cannot be analyzed by law of equilibrium equation alone. It needs some additional equation, additional compatibility equation to solve a structure. Then flexibility matrix is the one of the method of analysis of force method of analysis of structure. So, in this force method, forces are treated as unknown. Then these unknown forces are determined with the help of additional compatibility equations. Then, so first let us see the step by step procedure. So, first step is determine the degree of static indeterminacy of the structure, degree of static indeterminacy or redundancy of the structure, and also choose the redundants. Then second step is remove the redundant and assign one coordinates in the direction of each redundant. Okay. So, we have to remove the redundant, then apply coordinates for each redundants. Then the number of coordinates will be equal to the number of redundants, and also develop the flexibility matrix for the above assigned coordinates. Then third step is remove the redundant and find the deflection in the direction of assigned coordinates due to given system of loading. When the redundant are released, then the structure or determinate, which is called as a released structure or basic determinate structure or primary structure. In the third step, so what we are going to do is, so we have to remove the redundant. So, we are already in the first step we selected the redundant. Now, we have to remove the redundant, it becomes a primary structure, it is subjected to some system of forces. Then we should determine the deflections in the assigned coordinate direction. So, let due to the given loading, the deflection in the direction of coordinates are delta 1L, delta 2L up to delta n. Delta 1L means a deflection at the coordinate 1, then delta 2 means a deflection at a second coordinate. Then fourth step. So, what is the fourth step? Fourth step, remove the given loading and apply the redundant reaction in the direction of assigned coordinates. Now, what should we do means, so we should remove the external forces, system of forces, remove the external forces. Only we should consider that primary structure, but we also apply the redundant reaction in the direction of assigned coordinates. Then find the displacement in the direction of assigned coordinates 1, 2 and up to L. So, let delta 1 r, delta 2 r up to delta n r or the displacement caused by redundance in the direction of coordinate. So, this can be written as delta 1 r is equal to f 11 r plus f 12 r 2 plus so on plus f 1 n r. So, in this case we are determining delta 1 r and delta 2 r. So, these are the things, these are the deflection induced by the redundant reaction. So, initially we do not know the resultant reaction. So, therefore, it can be written in the form of flexibility coefficients. So, therefore, this is delta 1 r equal to f11 is the flexibility coefficient into r1 plus f12 into r2 and so on, like delta 2r is equal to f21 into r1 plus f22 into r2 plus so on. So, like this it can goes. Then finally, so it can be represented in a matrix form. So, it is a system of equations, system of linear equations. So, it can be easily represented in a matrix form. So, delta 1 r, delta 2 r matrix is equal to f11, f12 up to f1n, then second row is f21, f22, fn and so on. So, it is a flexibility matrix times redundant reaction r1, r2 and rn. So, take this as equation 1. Then step 5 is the final displacement in the direction of coordinates will be the final displacement, the net displacement in the direction of coordinates, assigned coordinates is equal to delta is equal to deflection due to a system of loading, external loading. then deflection due to redundant reaction. So, add these two, which gives the resultant reaction, resultant displacement. From that, the redundant displacement delta 1 r delta 2 r is equal to delta 1 minus delta 1 l delta 2 minus delta 2 l. So, again it can be represented in a matrix form. It can be, it seems like this: delta 1 r delta 2 r delta n r matrix is equal to delta 1 minus delta 1 l delta 2 minus delta 2 l. Delta 1 means the final displacement, net displacement at the assigned coordinates. Delta 1 l means deflection, displacement at the coordinate 1 due to the system of external loading. So, deflection due to external loadings in a primary structure. Then substitute 1 in 2, substitute equation 1 in 2. So, delta 1 r delta 2 r matrix is equal to flexibility matrix into reaction. So, F into R, F matrix, it can be simply written as this is F matrix into R matrix is equal to delta net matrix, sorry, is equal to delta R redundant reaction matrix. Okay. So, finally, the redundant reaction R1, R2, Rn matrix is equal to flexibility inverse, okay, F11, F21 and so on, F21, F22 and so on, and finally, Fn1, Fn2, Fnn inverse times delta 1 minus delta 1l, delta 2 minus delta 2l, delta n minus delta nl. So, from that finally, we determine the redundant reactions. Then step 6, knowing the redundance, compute the internal member force by using equation of equilibrium. Just apply equilibrium equation, we determine the other reactions, other unknown forces, unknown support reactions. Then finally, we draw the shear force and bending moment diagram.